Hey guys, welcome to College Netted Engineering with Bongani Gumede. And today we'll be looking at sequence 2. Remember last time we covered sequence 1, so today we'll be looking at sequence 2. And this is what the statement says. It says that motor 2 cannot be started before motor 1. Still like last time, motor 1 must operate first before motor 2. Otherwise, motor 2 won't operate. So then the second statement says both motors can be stopped independently. Remember, at the sequence 1, it's only one. If you stop motor 1, all of the motors stop. But now, if you stop one, that one stops only. So it says both motors, both of them can be stopped independently. It means that you can stop motor 1 and it will not affect motor 2. You can stop motor 2 and it will not affect motor 1. But the only thing is that before you can start motor 2, your motor 1 has to run. So this is the same main circuit. Main circuit remains the same most of the times. So you can pause the video and look at how the main circuit is. You have your 2 contactors here, you have your 2 overload, and then you have your 2 motors. You have your MCB, you have your supply line. So that was just the easy part, and comes the hardest part according to many people. But I don't know what's hard about this one, because you just have to understand the statement and then everything else will flow simple. So let's start first. We have your line here, your circuit breaker swinging pull, and then you have your 95, 96 of overload 1. Then you have your 95, 96 of your overload 2. And then you have your emergency stop. And then this side will be motor 1, this other side will be motor 2. So they say motor 1 must start first, and it can stop on its own. It means that there's nothing wrong with motor 1, then we can draw our direct on line. Should be stop button, stop 1, and then we have our start button. The normal open of K1, and you have K1, A1, A2, and this will return to your neutral for your life. So this is where the tricky part comes. But first of all, always remember, draw the direct online first, and then after drawing the direct online, then you can start to take out what's not supposed to be there and add what's supposed to be there. Now this is motor 1 and motor 2. This is how we are going to draw it. Our stop 2. And then you have your A1, A2, K2, and then normally open of K2, K2. So this is a normal DOL, So it says that the statement says that motor 2 cannot be started before motor 1, and both motors can be stopped independently. So if now we start this motor will also start. If this motor we did not start it, and we try to start this one, this motor will still start. But now we want to make motor 2 not to start before motor 1. What we can do is to add a normally open. The normal open of, we'll say normal open of K1. We are on the side of K2, or the side of contactor 2, or side of motor 2. But on this side, we are adding a normal open, this one, but of K1, not of K2, of K1. Here is a normal open of K2, 13, 14. Okay, 13, 14, 3, 4, 3, 4. So what is happening now is that we have added a normal open for K1. Let me show you now. Now you need to pay attention. We are starting this motor. And when we start this motor, this coil will energize. And when this coil energizes, because of it's a coil for contactor 1, everything that falls under contactor 1, it will change its position. So, coil energize, and then this one closes. And when it closes, then you can be able to start motor 2. But now, there's a tricky part that I want you to understand. Most of you, the question you might be asking is this: why is it that we put the normal open here and we don't put it here, or we don't put it here? And why do I say that if we put the normally open here, we'll be able to stop the motor and start it after this one is started? Remember, this is your retainer. 13 and 14 is called a retainer. Retainer. And the retainer is dependent on that. When you press this button, then this one becomes energized, so that this one can be able to close the contact. When the coil energizes, when contactor 2 energizes its coil, its contact will change the position. This one will become normally closed and is called a retainer. But this one, it will still be open. So current will flow through this side only. But now, the reason why we are putting this normally open this side, it is so that you cannot be able to energize this motor, this coil, when you press the start button. Because of, this is not the start button. This one is not the start button, this is just a retainer. What I'm trying to say is that a push button operates like this. Ne? When a push button of a start button operates like this. When you press the start button, it goes back. And when it goes back, it becomes normal open, because of its original state is that it's always normal open. It becomes normally closed when you press. But immediately when you remove your finger, it becomes normal open. So that is why we use a retainer. A retainer is the one that will be responsible to close the circuit, and this one will be your retainer. So this one will remain open, but this one will continue to remain closed. So let me explain it better for everyone to understand. Motor 1 must run first before motor 2. And every motor must be stopped independently. So when it's like this, if I stop, let's say this one energizes and is running. When it's running, this one will close. And when it's closed, current will be able to flow. Then if I start this side, current is able to flow. And I'm able to stop this one without affecting this one. And even if I stop motor 1, The only thing that will happen is that this one will open here, but this one will continue to remain being closed because it's just a retainer. It will close until here you stop, or you stop here. So that's it. It's not difficult, very simple. Let's go back to its normal positions. Yeah. So that's it about sequence 2. It's actually not hard. We have placed a normal open of K1 on motor 2, so that if we start motor 1, that side can become normally closed. So that's it. It's not actually hard. It's just that you have to really pay attention to detail and also understand your statement. So in this case, when you stop motor 1, it will stop on its own, and motor 2 will stop on its own. When you try to run motor 2 without starting this one first, it won't run this one. It won't run. Because of, remember, when you press the stop button, this is your stop button. Current must flow through here, not through there. It must first flow through here to energize this one, so that this one can close. Immediately, this thing, it works very quickly. Immediately when you press this one, you press the start button, already this one will close very quickly. So it's not like you're going to wait for 20 minutes to say, let me put my finger, not remove it, it will maybe after 20 minutes. No, immediately when you press the retainer, it closes. So current escapes on the other side while there's an open link on this start button. So thank you for watching. Let's meet on the next video. Sharp.